Let's solve LeetCode 198 house robbers. So I am a robber and I'm planning to rob all the houses on the street. And each house has a certain amount of money stashed. So the red house has 2, the pink house has 5, the brown house has 1, etc. Okay, so the condition that they've given is that I cannot rob adjacent houses. So if I'm robbing the red house, then I cannot rob the pink house. I'll have to rob the brown house or any of the other houses. If I rob the pink house, then I have to rob only the aqua house and not the brown house. Okay, so my initial thought process was, if I cannot rob subsequent houses, then I can rob the house that is just after it. So if I rob the house having 2, then I can go to the house having 1, then 4, then 6. We can do like a decision tree where we have a start, and then if we rob the house with 2, then we cannot do it for 5 and we'll have to go to 1, and then so on. Similarly, if we start with 5, then we cannot do 1 and we'll have to go to 6. Okay, so let's code the solution. So I will have two variables, answer 1 and answer 2, and this will store the decision for whether or not to take the left subtree or the right subtree. So now I will have one for loop that will go from 0 to n in the nums array, and we will just add it to this answer 1. And what we have to do is we have to start from the value 0 and it should go to the value n, skipping the middle terms. So we will start from 0 and then we will go to n with having a increment of 2. Similarly, we will do the same thing but for the left subtree, which will start from a value of 1, and we will add this to answer 2. Now if we just get the max of answer 1 and answer 2 and store it, this will be the maximum value, right? So return answer. As you can see, this value is actually not correct. Now the problem was over here, when we took the non-adjacent value 2 and 1, we added and we got 3, and what we should have instead done was we should have taken the value 2 and got 4. So to solve this, what we can actually do is we are taking either 2 or we are taking this 1, right? Instead of looking at it as taking the value 2 and then taking value of 1 over here, what if we can take the value of 2 and then after that we can choose which value is the best from here, right? So we'll have to find the rob values of these two houses, and clearly robbing 2 would be better than robbing 1. So it becomes a sub-array question where this is one value and we have to add it to the sub-array that is over here. We can see this over here as start. We can either choose 2, otherwise we can choose to rob the subarray 1 to 2, which is 1 to 2, and we can choose the value of 2. If we choose the value of 2, we have to skip this one, and then we can choose to rob the subarray from 1 to 2 and so on. Okay, so here only there's 1 to 2, and then we can decide over here which is the best option. If we choose 2, then we get the answer 4, and if we choose over here as 1 to 2, we will get the answer 3, which is not right. Let's look at another way to visualize this problem. So what I'm going to do is I'm going to rob two values. So if I start with robbing 2, then I'll have to rob this subarray also, and then this subarray is now split into another part, which is robbing either 1 or 6. Similarly, if I rob 1, then I'll have to choose to rob 4 to 7, and if I rob 4 to 7 by using recursion, I have this value over here, rob of array, and I have array of 0 plus rob of array of 2 to n. So I'm going to choose the value that is maximum, that is robbing this, and then robbing the subarray of this. Otherwise, I'm going to rob from 5 to 7, and then I'm going to assign that to my value. I have 2 and 5. If I take 2, then I will have to rob this subarray, and this subarray I can choose it as robbing 1 or robbing 6. Let's say we choose robbing 1, then I will do the same thing, and I cannot rob 6, so I have to rob 4 to 7, and I'll say I'll rob 4. Similarly, if I did take 2 and if I don't want to rob 1, I will rob 6 instead. So I'm going to add this 6 to this 2, and I'm going to get 8, and similarly I will rob everything else. So let's try coding the solution. Okay, so what I'm going to do is I'm going to code a recursion, right? So I'll have to have a function define rob1 of array. Okay, so now I'm going to get the max of array of 1 of 0 plus rob1 of array of 1 to n, 2 to n, right? Which is, so this statement means nothing but choosing choice 1, that is robbing the first house and then taking the subarray of the non-adjacent houses. And now if I don't take this option of robbing house 1, I'll have to rob house 2, house 2, that will go from 1 to n. So I will rob this. Now we also need to return this value and place a check, so that in case if array is not there, then we'll return 0. So now I will return rob1 of the value, right? So our time limit is exceeded, meaning that this is not entirely the right solution. Let's try to improve it further. Okay, so let's say that I robbed in this manner. Now I could have either robbed the first house and then robbed the fourth house also, and that would have actually given me a bigger answer, that is like 20, right? But if I do this, I've already solved this question, right? Now I want to save this question in our memory, so that if I rob the second house, I will know already the value of solving all of this. So we just memorize this value and then we'll add it to this 5. Okay, so now to memorize the value, I'm going to use a hash map. And I'm going to send this hash map inside our function. Now over here, we will get our hash map. If the key of the length of the array is there in the hash map, then we'll just return the value. Okay. And then if it's not there in the hash map, then we will add it to the hash map. Okay, I forgot to add the hash map to this. And I don't know how to do this correctly. Okay, so we got the value. Let's try submitting this now. And yes, we have been accepted. Originally this was like 80% or something like that, but it keeps changing, so we got a good value. Thank you.